So my name's Colin Kestel, Associate Professor Colin Kestel. I work in two places. I work in the Faculty of Engineering, Computer and Mathematical Sciences, and I also teach in the School of Mechanical Engineering, which is one of the schools in the faculty. I teach design. If you start up here, you'll see me in the first year. I'll be teaching you design graphics. So I'm here, in this capacity, I'm here to talk to you for this half hour about mechanical engineering. Those of you who didn't come to the faculty talk this morning, you might want to stay around after this, because from 3:30 onwards I'll be talking about the faculty in general. So I've had a lot of questions today already about what is an engineer, what does an engineer do? So I thought I'd start off with a little video. See if this will play.
I've been sitting here for nearly a minute without entertainment.
Change the battery in the remote. The one on the left.
The one on the left? Well, that's just spooky.
Not really. I have the knack.
The knack?
For technology. My mom says I always have.
I'm worried about little Dilbert. He's not like other kids.
What do you mean?
Yesterday, I left him alone for a minute, and he disassembled the TV, our clock, and the stereo.
That's perfectly normal. Kids take things apart.
Oh.
The part that worries me is he used the components to build a ham radio set.
Oh dear.
Is that bad?
Normally I want to run an EEG on, but the machine isn't working. It's worse than I feared.
What is it?
I'm afraid your son has the knack.
The Mac.
The knack. It's a rare condition characterized by an extreme intuition about all things mechanical and electrical and other social entities.
Can he lead a normal life?
No. You'll be an engineer. There. Don't blame yourself.
Will he go away over time?
It might, but pray it doesn't. If an engineer loses the knack, the results can be devastating.
Thanks for filling in for our regular doctor on such short notice.
I was in the neighborhood.
So hopefully that gives you a bit of an idea about what an engineer is. More specifically, I want to talk about what a mechanical engineer is. And a mechanical engineer is somebody that not only designs, but engineers stuff. And what I mean by, I'm using the word stuff because it's very hard to be specific, because there's a smorgasbord of stuff that mechanical engineers design, and it could be something as basic as the toothbrush that you use, well, that I hope you use in the morning, or a spaceship, stuff that goes into space. So the very chairs that you're sitting on, the podiums that I'm using here, all the stuff that these computers are sitting on, the audio system, all the techno stuff up there, it's all been engineered, it's all been designed by people, but not just designed, not just drawn up to look pretty, but there's been teams of people working on it to make sure it's going to be robust enough and fit for purpose. So it's going to do its job. It's going to do the job that it's intended to do for the time span that it's intended to operate within. So it's a very, very diverse range of stuff that the mechanical engineers get involved with. And that's really the best slide I can think of putting up to show you that range from toothbrushes right through to space vehicles. So in the School of Mechanical Engineering, which as I say is part of at the Faculty of Engineering, Computer and Mathematical Sciences, we've got a number of programs. 1, 2, 3, 4, 5 basic degree programs there. I say basic, they're all honours degrees. So they're all 4-year programs. If you like the vanilla flavoured version of mechanical engineering, which is probably the one to choose if you're not quite sure about the specific area of engineering that you want to go into, but you know that you want to design and engineer stuff, then mechanical engineering is probably the best program to choose. It's the oldest, most established program. It was right there at the beginning of our school back in 1946. Since then, we've introduced a mechatronic program, and that's in recognition of the fact that the world's becoming more automated. There's more sort of robotic type things and automatic type things in our everyday life. So a mechatronic engineer, for example, would have the majority of the skills and attributes of a mechanical engineer, but also an in-depth knowledge of automation and robotics and more knowledge of computer systems as well for automating production lines, building robots. One of my students who's recently graduated, her goal is to be the first person to design a bionic eye. So obviously there's going to be a lot of computer type stuff and automated type stuff that goes into that. We've also got a mechanical and aerospace degree, and what we're getting into now, if you like, is product specialisation. Aerospace is anything that's up in the sky. My background is I was an aerospace engineer. I did my apprenticeship with British Aerospace, testing missiles, moved on to work on satellites, came to Australia and I worked in the defence area testing, bits of boats, bits of ships, bits of tanks, all the stuff that the Army wanted testing, and some live ammunition as well. Sustainability is a very, very important factor now with engineering design, so much so that we've got a program that focuses and specialises on it. Very strong flavours in wind energy, solar energy, but not just energy, in terms of sustainable design. So designing everyday products that have a sustainable focus. For example, the materials might be recyclable and they might use a very small amount of energy. Mechanical and sports engineering, where again the focus there is in the sporting area, where you might be looking at designing equipment to enhance the performance of our athletes. Not that you're mechanising athletes as they're doing a 100 metres sprint, but you might be helping them with designing stuff that helps them train. It could be something as basic as their shoe, it could be a new type of starting block or whatever. So all of the mechanisms and the equipment that helps enhance the performance of our athletes. And that is an attractive program to a lot of sports-minded people who tend to see it an opportunity to mix their sporting interests with their vocation as well. So if you graduate, if you choose to take on one of those programs and you graduate with one of our degrees, you'll be pleased to know it's accredited. What accredited means is that it ultimately will satisfy the first stage of Engineers Australia accreditation program. And it means that you started your pathway to becoming a chartered engineer. Okay, so once you're a chartered engineer, you can sign off on stuff. In Queensland, you're not allowed to sign off on designs unless you are a chartered engineer. It's the way the rest of Australia is going to be going. But more importantly as well, it gives you global opportunities where you can travel overseas. And Australia's got Engineers Australia. England's got the Institute of Mechanical Engineers. America's got something else, I'm not sure what it is. But all of these societies all have these agreements to recognise qualification under what's called the Washington Accord. So you can go and practice at a variety of other countries that are listed up here. As I say, all of our programs are accredited by Engineers Australia. So just to repeat what I've already stolen my material for these next few slides. So I'm just going to repeat, I suppose, what our program's all about. Mechanical engineering, as I say, if you're not quite sure whether you definitely want to go and design rockets or be Australia's next astronaut, or whether you want to work on sports equipment, or whether you want to work in the realm of sustainable engineering, if you haven't quite made your mind up, mechanical engineering is the one to choose. It's very broad in its focus, and it's broad in terms of the job opportunities that it offers you at the end of it as well. The other thing, as I'm thinking about it and looking at this slide here, all of the programs that I've put up, they all have a common first year. So if you can't make your mind up right now, maybe it's a good idea to put down mechanical engineering as your first preference, sports engineering as your second, or vice versa, aerospace as your third. And you've got multiple preferences there, but fundamentally getting into the same program. If your grade point average is good, you can quite easily transfer across from one to the other. Once you've seen what the person sitting next to you is doing, and you think, oh, I prefer that than what I'm doing. So you've got that opportunity to move around inside our school once you start. Mechatronics, as I say, there's a couple of slides there just to reiterate the point I made earlier. This is where you're spending more of a focus on the automation of mechanisms. I went to Arnott's Biscuits factory a few years ago, and you wouldn't think that that's the forefront of automated technology until you see what's going on their production line, and it's quite amazing. And if you used to look at this factory that were producing biscuits, the way it's all automated, the way that all these sort of robots are picking up and turning biscuits is very, very freaky. But you know, production lines might not be your thing. You might want to design robots, walking robots, or whatever. If you know that you want to get into, if you like, that hybrid mix of electronic engineering, automation, computer science, and mechanical engineering, that's the one to choose. Okay, it's a very good hybrid program. Mechanical and aerospace, as I say, product focus, anything that's in the sky. You could start your own company designing and building hot air balloons, or you could be part of Australia's space race, so who knows. Mechanical and sports, again, who's been on the tours, the tours so far? Anyone? Hands? Yeah? Okay, those that have would have seen our sports lab. We've got a very good sports lab, and we've got particular interest in the sports lab of looking at the human function so that we can match machine to the human and optimize, as I say, athletes' training regimes and the equipment that helps them fine-tuning their athleticism. Sustainable energy. A lot of research going on in sustainable energy in our school as well. We've been looking at the noise from wind farms, very controversial topic at the moment, on whether the low frequency noise that comes off of wind farms actually causes health issues. So we're looking at that at the moment. I'm not going to say whether it does or whether it doesn't, just in case somebody has a go at me. That is quite a controversial issue at the moment. So a lot of research going there. And the other thing to point out there on that note is that we are at the forefront of research. We are doing research, and that research is continually fed into the curriculum of our programs. Now, there's 3 pie charts there. I'm not going to talk about the specifics, but you can see there's a little bit of a difference in the mix there between the programs. But the thing that's common to all of them, you can see there is some electronics, there's design in all of them, there's certainly maths, there's engineering science, and there's a degree of professional practice, if you like, the soft skills, where we're not just teaching you how to apply all the numbers, but we're teaching you to communicate and to work with each other in teams as well. So that's common to all of our programs, but it's a bit of a different mix in each of them. When I say program, by the way, I should point out, I mean degree. Okay, so a degree is seen as a program, and the courses are all the courses that make up that program. So what will you study? Well, it varies a little bit from level 1 to level 4 because you have to lay down a very firm foundation. And we believe that means basically honing your mathematical and science skills right at the foundation level, and then starting to build upon those by applying them more and more and more until you're actually using those skills in a very pragmatic way and actually designing and building stuff. And we do that. We do that in a number of steps. Ultimately, in your professional year at level 4, the biggest chunk of your subject choice is your final year project, and that's when you get to design and to engineer and to build and to mess about with some really cool stuff. Okay, so very team orientated. We try and encourage people to work in teams because there's not too many individual engineers out there. There's a few, but generally speaking, you're going to be working in teams, so we try to develop your team skills while you're part of our school. Now, we try and put projects into all year levels so that straight away students can see what engineering is all about. Very important in the first year because, as I say, we build on the foundation of a strong foundation of maths and sciences. But nonetheless, even in week 1, we get all of our students in a design and build contest where they're working with more senior students in a bit of a competitive, fun environment where there's a big barbecue at the end of the weekend and a winner with prizes. So there's a project in the first year. Again, there's a design and build challenge in the second year where the winners of that challenge go on and compete against other universities at a national level. It's called the Warman Cup. Level 3, we start looking at the nitty-gritty of design and concentrate on the communication. We get students designing stuff and producing full sets of engineering drawings and technical reports. And when they've got those skills all finely tuned, we then let them loose at 4th year to design some really sort of cool projects. So there's a few pictures here of some projects. The best thing I can probably do though is take you back to a bit of an old video, but it's a good one because it's professionally put together with about our engineering expo, which shows you some of our students' designs and build projects. Is that going to play? Oh yeah, good. So all of these have been designed and built by students. So there was a bit of an idea. Actually, that electric motorbike I remember well. That was my students that designed and built that. I shouldn't admit to this, but I had a bit of a ride of it, and I'm not very good at riding a motorbike, and I fell off and broke my foot. But that's a story for another time. The one at the top there is a very interesting one. We've done a few things on motorbikes. How am I going for time? I'm okay. Done a few things. I could talk forever on this stuff. That one on the top left there, that's an author sitting on there called Paul Carter. He wrote a few books. One was called Don't Tell Mum I Work on the Oil Rigs. She thinks I'm a piano player in a whorehouse. Anyone read that? So it's a really good book about life on the oil rigs. And he wrote that book. He wrote a follow-up book. Then he wrote a book where he drove that bike there, this one here, Betty, all the way around Australia. Oh, there it is again, that one there. And I remember when we were riding Betty from Darwin to Adelaide, we went past Lake Gairdner, and we came up with this harebrained idea of building a world record braking, not baking, motorbike. This one up the top there, which is a 2.5 litre turbocharged biodiesel engine, runs on basically recycled fish and chip oil. And we got that up to Lake Gairdner only this March. And Paul's going to hate me for saying this, but the bike was capable of breaking the record. He got up very close to it and he lost his bottle. He just didn't have any, he couldn't go any faster. All the guys that were racing on the salt were telling him, no, you just got to push past that fear. You feel like you're on ice, but you won't fall over. You just got to push past it. But he didn't. So we're going to we'll probably go up again this March and just see if we can get the world land speed record for a biodiesel motorbike under our belt. Also, we've got a team that you've probably seen exhibiting their car, working on building small open-wheeled race cars. So there's a lot of really cool projects that are out there. Well, who employ our engineers? Well, nearly, it's an endless list. This is just a few bullet points that are on this slide. But I have immense amount of joy when I go to a particular company for the first time to have a chat with people, walk down the corridor, and it's, hey Colin, you know, it's one of my old students that I've met. So the job opportunities are really good for our graduates, and there's a vast variety there, as you can see, of areas that people can become employed in. And it's very difficult to say what an engineer will do because there's so many different types of engineers and there's so many different engineering roles within companies. So with that in mind, just think of all the opportunities that are out there, just the fact there's that huge variety. So what is a mechanical engineer? Well, again, should I be recording? That record thing's come up. I'll just make it go away then. Dismiss for 2 minutes. There we go. You can edit that out, can't you, on the camera? I'm sure you can. Good. Yeah. Okay. What is a mechanical engineer? Well, I'm getting to the area now. I'm starting to repeat myself. But designing stuff, not just designing stuff, but engineering stuff, as I say, will it be strong enough? So use mathematical simulations to figure out when stuff's going to break. Use computerized systems to help with those mathematical simulations to see whether something's going to be aerodynamic enough and cut through the air as quickly as it possibly can, or cut through the water as quickly and as efficiently as it possibly can. So these are the sort of tools that mechanical engineers do to engineer products, so that ultimately when a product hits the market, it's fit for purpose. Not just fit for purpose, but also looks good as well. So it is important. Image isn't everything, but it's certainly something, otherwise people don't buy things. So a bit more of a list there. I don't think I'm going to read all that list out, so I could just leave it up there for a few seconds just for you to digest it. But again, you can see it's a vast array of things that mechanical engineers can become involved in. It doesn't mean an engineer has got to do all of these. It means engineers can become involved in all of these aspects. Mechatronic engineer, again, control, automation, robotics. So a great deal of opportunities there, particularly when you think about how automated the world is now. I mean, there's self-ordering fridges nowadays. I mean, gone are the days where a fridge was just a pump and a sort of an insulated box. It knows when it needs to reorder from online supermarkets. So the level of automation now is absolutely scary. In actual fact, yeah, that's why I put that Terminator picture up there. You know, who knows where it's leading? Skynet and Terminator stuff. Hopefully not. Anyway, it just seemed like a good idea at the time to put that picture up there. So again, what do mechatronic engineers do? A lot of stuff in hidden places that you might not realise. I mean, if you used to lift the bonnet of a car nowadays, I mean, if you're my age, you wouldn't recognise it compared to the cars that I used to drive when I was a kid. But they're computers, not just one computers, but you've got multiple computers under the bonnet of the car, all talking to each other. So it's, again, all this automation is all hidden and in obvious places as well. Aerospace engineer, few pictures on the side there. Rapier missile, working on satellites, Airbus Industries. I haven't got my glasses. Does that say 2 minutes? 2 minutes. I could read it, really. I'm messing with you, sorry. Sports engineer, again, working on sport products. Shoes, would you believe? Something as basic as the shoe. You know, there's a lot of ergonomics there, fitting a product to the wearer, and basically equipment to optimise the performance of sporting athletes. Sustainable energy engineering, pretty much covered that already. Some pictures there of wind farms, sea farms, and the like. So grabbing hold of natural resources and in harnessing the energy from them. So summary, it's a great place to study. It's a really good place to study. If you come and study in our school, you'll feel that you're part of a family. It's a big university, okay, that's broken down into faculties. In our school, it does have that sort of family and team spirit. So it's a great place to study. You'll be exposed to world-leading research and also award-winning lecturers as well, national award-winning lecturers as well. So 85% of engineers are employed within 4 months of graduating. Okay, what about the other 15%? Well, they decide to take a break. They decide to go out and maybe have a gap year at the end of their degree because they've worked hard enough. So generally, we find there are very few cases of our graduates who have trouble getting a job. So if you want to see in the flesh, so to speak, the stuff that was going on in that video, think of coming along to our Mech Expo in October. It is October. It's a really good demonstration of what our current students are currently working on, and I think it will give you a very, very good idea of what you will be working on as one of our students. I've had a fantastic time being employed as an engineer before I became an academic, and I know that if you choose your job wisely at the end of it, then you too will also have an incredible time. So, thank you.